So we're a small crowd today. We can also make it more interactive, whichever works. But today, what I'll be talking about is Inco, what we call the Universal Confidential Computing Network. So today, all the L1, L2s have one thing in common, is that everything is transparent. Now, we believe that there needs to be a minimum of confidentiality in order to drive for mass adoption. So a couple examples. When you use crypto as your bank account today, everything's transparent. Everyone knows exactly how much money you have. It's very, very inconvenient. And same with payroll. If you do payroll in crypto, everyone within the company knows how much they're making. And this is also a known bad practice in Web 2 already, right? Second is institutions and enterprises are still having a hard time entering this space. They have compliance reasons, they have trade secrets. Just overall, it doesn't really make sense for them to enter the public blockchain space. And then lastly, there are just a lot of use cases that wouldn't make sense without hidden information. So think of card games, private voting, or any blind auction. Now, at Inco, what we're building is what we believe to be the fourth missing layer of the blockchain stack. So, in the modular world, you have folks like Celestia building the DA layer, so DA as a service. What Inco is focused on is really on confidential computing. So we believe that this is the next frontier. Just how like Chainlink enabled a suite of DeFi protocols to unfold over the years with money markets, derivatives markets. With Inco, we will grow the pie of what's possible in Web3 across DeFi, gaming, asset management, and infrastructure. And so with this, we plan on unlocking the next $1 trillion of economic opportunities for builders in general. So obviously, everyone here is at the coffee house or coffee shop. So everyone's more or less already familiar with the FHE. But for folks who are non-technical, folks who are hearing about this for the first time, FHE allows you to encrypt data, but also compute on top of it without having to decrypt. And so imagine if you had a cat picture, you could encrypt this cat picture, still modify every single pixel by adding, dividing, multiplying without having to decrypt. And by the time you decrypt, now you have this magical filter. So what makes FHE really stand out compared to more legacy solutions, notably ZK, is really around this idea of composability. So why does composability matter in crypto? It matters because blockchains are multiplayer systems. Everyone has to interact with each other or interact with some kind of shared private state. So imagine if you have DeFi, right? You want to be able to interact with some kind of pool. So composability actually matters a lot because you want this to happen in a permissionless fashion instead of doing off-chain coordination in the case of ZK. Now, Inco is a layer 1 blockchain, so we provide confidential compute, consensus, storage, and also we have our own economic security. The goal here is to enable confidential compute to existing blockchains, such as Ethereum, the major blockchains, and also down the line, the rest of the blockchains. So we believe we offer the most intuitive way to write FHE code. So just to get started, you just have to learn Solidity and then write this code in Solidity. But with that, you also get to directly benefit from the existing user base and also TVL from existing chains. And so the way we design our MPC network is also a little bit more modular here. The idea is that we will have different MPC networks that you can trust, but you can also bring in your own keys if you, let's say, have specific needs. So for example, if you are located in specific areas where you have jurisdiction requirements, then you could trust a MPC network that's based on that. You can also trust different size, different tech, and also different brand. So to solve the cold start problem for new layer 1 blockchains, we utilize eigenlayer. So the cold start problem is this: if you're a new layer 1, typically your market cap won't be as high, so you have more volatility. And because your market cap is volatile, you need to give out more inflation to your stakers because they have this inventory risk, right? So typical layer 1s have to give out 20 to 50%. So with eigenlayer, by leveraging the market cap of ETH that's more stable, we can actually avoid this problem. And second is we also benefit from additional economic security since day one. So to get started, it's extremely intuitive. We're compatible with Ethereum toolsets. So we get started with Hard Hat, Remix, MetaMask. And there are quite a bit of a wide range of support for operations and also comparison. So this is where you can really get to unleash your creativity. So if you want to build something like a private AMM, any type of like confidential gaming, these operations will help you essentially achieve all sorts of logic. And just to walk through a couple of use cases, the simplest form, a confidential. All right, it's a little hot in here, losing my voice. Okay, just a couple of examples to reillustrate what sorts of new use cases you can build using FHE. This is probably the simplest example for all the folks who are already familiar, with crypto, ERC20s. It's just a mapping of your address to a balance. In the context of FHE, what you have is you can have private states on chain. So essentially, here is just a mapping of address to an encrypted balance. Now, if Bob transfers money to Alice, what happens is that you are sending an encrypted amount and then adding that to an encrypted balance and also updating your encrypted balance. An interesting point here, if you were to contrast this with something that's more ZK-based like Tornado Cash, the sender recipient actually is known, right? You can follow the flow of funds. It's just the amount that's hidden. Another example is literally just card games, on-chain poker, right? So it's crazy to think that crypto as an industry still doesn't have fully on-chain poker. There are a couple of reasons for that. So one, on existing blockchains, you cannot hide information. Poker is a bluffing game. So without this capability, this game would not make any sense. The second thing is, in this game, you need to generate hidden cards, right? And the challenge with generating hidden cards is that today, all the existing VRF solutions, including Chainlink, only offer plaintext randomness. So I would say this is also what makes FHE stand out here, is that you can generate these hidden randomness, enable these sorts of use cases. Another example I'd like to talk about is this idea of dynamic DID. The idea of DID is that you can have your own on-chain identity. So on the left, the way it typically happens is that you will KYC with a DID provider, so it could be Binance. They will check your ID, and then they will send you a soulbound NFT that says, are you over 18? Are you in Europe? Is your credit score over 700? Now, this is quite inconvenient because all this information is public, known. The concept of dynamic DID is that you can store an encrypted piece of information on-chain and then use specific functions to query insights. So in this example, maybe for a casino dApp, I just want you to know I'm over 18, nothing else. Maybe for Goldfinch, I just want you to know I have a good credit score. It's dynamic in a way that this DID layer is programmable, but also these information, whether it's your age, credit score, or location, could change over time. So if you have a DID layer on chain that's composable, this information can also be updated with other dApps that interact with it. The way this works in practice is actually extremely straightforward. So you use FHE comparison, so tfhe.gt here. All you do is you compare if a user credit score is above 700, and you decrypt that insight, right? So very straightforward. And I want to point out that this is an experience that we already have in Web 2. If you think about Google Auth, when you connect to different applications, you selectively choose which piece of information you want them to access, right? So whether it's your contact information, your calendar, or your Google Drive, right? So a lot of the things that we do at Inco is actually bring in a lot of the Web 2 experiences to Web 3 that are missing, and they don't necessarily have to do with privacy. Privacy, as a whole, is just a subset. But like I said here, this is, very much just enabling new form factors that we are already familiar with Web 2, and just bringing this to Web 3. So we are hosting the ETH Global Hackathon this weekend, Friday to Sunday. So if you want to try out the technology, build new use cases, definitely this will be a great moment to do it. Our entire team is going to be there. We have 10K in bounties, so 6K in the gaming track, and then 4K as open innovation. So in terms of gaming, if you think about all the games that exist today in Web3, they're not that challenging. And the reason why is all this information is known. All the fun game mechanics we have in Web 2 require some kind of hidden information, right? Whether it's bluffing, fog of war, secret alliances, or the guessing games, or strategic RPG games. So we've hosted a few hackathons already, and then the learning is that a lot of folks actually do prefer building simple applications or very easy to build like games. But obviously, there's also a lot of opportunities to explore DeFi, also other types of infra, such as the DID layer. But the idea is, because you're enabling this concept of private state and private compute, you can really try to push the limit and see what other use cases can you build that couldn't be achieved otherwise. And then lastly, yes, we are launching a builders program pretty soon, so definitely a really good chance for us to get to know you. And then we're always here happy to provide feedback on your ideas and such. So definitely, yeah, come say hi to us. We do have a Notion page with a list of ideas that, if you like to get more inspiration, then definitely check out this list. They range everything from gaming, DeFi, to even just very simple applications. And really, yeah, check out this list. And we also have a Discord group, so we have a dev chat if you have any technical questions. And like I said, we're also happy to provide feedback if you have any questions. Telegram group, we do have a testnet running today where you can get testnet tokens. You can also deploy these simple applications. And so you get to play with this over the weekend at ETH Global. And yeah, that's it. So you can find more information about us. We also have a arcade page where there are a few simple dApps that are already deployed. Some of them are mini games like Fully On-Chain Mafia game. Some of them are your typical Hangman, slot machine. So a few experiences that you can already try out. And yeah, some other links for you to refer to here. So yeah, this concludes the presentation.
Any question, guys?
Thanks a lot for the presentation. A quick question about the use case with private blockchain, and specifically AMM. Can you share if you did any benchmarks in terms of amount of operations and how big can be the pool? Because as we heard on previous panel, if I'm not mistaken, it was something about like a maximum 10 transactions per second, which can be limited for AMM basically, because we need like order of magnitude more. But maybe you can share more benchmarks or at least your feeling when you were playing with this tech. Thank you.
That's a really good question. The way you want to think about this is what types of operations, FHE operations, you need to use to accomplish that use case. And obviously, there are operations that are going to be more expensive, such as divisions. The way you write code, I would say in FHE, is a similar way that you write code on Ethereum, which is you have to think about optimizing the number of steps, gas fees, things like that. Something like private AMM, ultimately depends on which version. There's V2, V3, V4. Depending on the complexity, you might have to tailor around some of the inefficiencies. But generally speaking, if you want to build a DEX with FHE, an AMM is probably the more realistic approach rather than a fully on-chain DEX, right? Just the same way you wouldn't build a fully on-chain DEX on Ethereum, you wouldn't build a fully on-chain FHE DEX on a FHE chain. It's just not, I'll say, realistic today. But if you want to think about designing around private AMMs, then yeah, there are ways that you could optimize. So some people have explored this area. We haven't done benchmark ourselves, but there are ways that you can also think about like batching trades, things like that. But in the context of private AMM, the more interesting area to explore is around how do you prevent information leakage, right? So this is where you enter a very different space around differential privacy. So you want to think about, if someone makes a trade before me and makes a trade after me, how can I make sure that they cannot reverse engineer the amount that I've swapped out, right? And so there's a whole lot of researchers areas that people look into this differential privacy approaches. So if you're coming to FHE Summit tomorrow, we also have Tarun from Gauntlet, who's actually going to present a topic on this specifically like confidential DeFi topic, is what are the missing pieces or components that people should think about when designing for confidential DeFi, because it does have additional requirements and design thinking that might not be as obvious as a regular DeFi.